Hey there, ready to demystify machine learning. Not just the definitions, but the really interesting stuff, how it's changing things right now and the breakthroughs happening at warp speed. Today's deep dive is all about getting you up to speed. And, lucky for us, we've got Machine Learning Techniques, a comprehensive guide from World Insider, fresh off the digital presses today. Talk about good timing.
Cutting edge is an understatement. So let's ditch the jargon and dive right in. What exactly is machine learning?
Imagine a computer program that doesn't just follow orders, but actually learns from experience. It's like instead of giving it a set of rules for every situation, we give it the ability to figure out those rules itself by analyzing mountains of data.
It's the difference between a recipe and a chef who learns by tasting and experimenting. Machine learning is all about algorithms that adapt, constantly refining their own models based on new information. And that's what makes it so powerful.
And a little unnerving.
Right.
A little bit, but also incredibly cool, especially when you think about how it's already impacting our lives. Personalized medicine. That's machine learning, crunching through your medical history to tailor treatments. Ever wonder how Spotify seems to read your mind with music recommendations? That's machine learning too.
It's easy to think of this as some far-off future tech, but the future is already here. To really wrap our heads around it, let's do a quick rewind, a little history lesson.
I'm always down for a good origin story.
Well, the seeds were planted way back in the 1950s with Alan Turing and his famous test for artificial intelligence. Then, in the 90s, neural networks, computer systems inspired by the structure of the human brain, started gaining traction.
Neural networks sounds intense.
They are. But hold on. Things get really interesting in the 2010s with the deep learning revolution. Imagine neural networks, but with layers upon layers of interconnected nodes, allowing them to process information in a way that's eerily similar to the human brain.
Okay, now my mind is officially blown, and from what I understand, things haven't slowed down one bit, especially with the rise of transformer models in the 2020s.
Those are the powerhouses behind those AI image generators everyone's talking about. Remember that photo of the Pope in a puffer jacket that went viral? AI generated?
Seriously, I had no idea. No wonder it feels like there's a new breakthrough every time I check the news.
Exactly. This rapid evolution is why we're doing this deep dive in the first place. Staying up to date is key. Now, to really understand the landscape, we need to talk about the different types of machine learning, because it's not a one-size-fits-all world.
More like a buffet of brain-bending algorithms, so what's on the menu?
Let's start with supervised learning. Think of it like teaching a dog a new trick. You provide the data, showing the dog what to do. You provide the answers, treats for getting it right, and the algorithm learns to make the connection.
Like, if I sit, I get a treat. Got it.
Exactly. A classic example is predicting house prices. We feed the algorithm tons of data about houses, square footage, location, number of bedrooms, along with their actual sale prices. The algorithm learns the patterns and can then predict the price of a new house based on its features.
That's so practical, like having a personal real estate analyst in your pocket. So, what's next on our algorithmic buffet?
Let's jump to the opposite end of the spectrum with unsupervised learning. This time, we're not giving the algorithm any specific instructions or right answers. Instead, we're saying, here's a mountain of data. Go wild and find the hidden patterns.
No pressure. Algorithm.
Think of it like Spotify discovering your new favorite band by analyzing your listening history and finding connections to artists you've never even heard of. It's all about uncovering those aha moments buried within the data itself.
Okay, that's seriously cool, but also a little spooky. It's like they know my case better than I do, so.
Yeah.
Supervised learning is like teaching with treats. Unsupervised learning is like setting a detective loose on a mystery. What other learning styles are out there?
Let's talk about reinforcement learning. This one's straight out of a sci-fi movie. Imagine training a self-driving car.
Okay, now we're talking.
The algorithm learns through trial and error, getting rewards for good decisions, like not crashing, and penalties for bad ones. It's a process of constantly adjusting its actions to maximize those rewards over time.
So it's like teaching a computer to ride a bike. Lots of wobbly starts, a few scrapes and bruises along the way, but eventually, it figures out how to stay upright and navigate the world on its own.
That's a great analogy. And then we have semi-supervised learning, which, as you might guess, is a blend of supervised and unsupervised approaches. Think of it as a student who can learn from both lectures and independent study to get some guidance, but also the freedom to explore and make connections on their own.
So we've got our diligent student, our detective, our self-driving car. Sounds like quite the crew. But this begs the question, why does understanding these different types of machine learning even matter?
Because just like you wouldn't use a hammer to tighten a screw, different machine learning tasks require different tools. Understanding these distinctions helps us choose the right approach for the job. Whether we're trying to predict stock prices, personalize medical treatments, or, you know, recommend your next earworm on Spotify.
Okay, so we've got our different types of machine learning, each with its own strengths and learning styles. But how do they actually work? What's going on under the hood?
That's where things get really exciting. Let's start with a few essential techniques that form the backbone of machine learning. First up, regression techniques. Because who doesn't love a good prediction?
Especially if it helps me make smarter decisions. But tell me, what kind of predictions are we talking about here?
Think continuous values, things like stock prices, sales figures, even predicting the temperature tomorrow. Regression techniques are all about finding relationships between variables, allowing us to make educated guesses about what might happen next.
So if I'm an investor, regression analysis could help me anticipate market trends. Or if I'm planning a picnic, it could tell me if I need to pack an extra sweater.
Exactly. The most basic technique is linear regression. Imagine drawing a straight line through a scatter plot of data points. It's all about finding the line that best fits the overall trend, even if not all the points fall perfectly on that line.
So it's about finding the average relationship, the general direction things are heading.
Precisely. But sometimes the straight line just doesn't cut it. That's where polynomial regression comes in. Imagine a curve that winds its way through the data, capturing those more complex, nonlinear relationships. It's like the difference between approximating a mountain range with a single straight line versus a more nuanced curve that captures the peaks and valleys.
Okay, so linear regression is our straight A student, following a predictable path, while polynomial regression is more of a free spirit, adapting to the curves life throws its way.
I like that. Now let's talk about a technique that often trips people up: logistic regression. Don't let the name fool you. It's actually used for classification, not regression.
Hold on, are you messing with me? First, you're comparing algorithms to students and free spirits, and now you're saying a technique called regression is actually used for something else entirely.
I know, it's a bit confusing, but think of it this way. Imagine you're building a system to screen loan applications. Logistic regression wouldn't try to predict the exact amount someone might default on. Instead, it would analyze their financial history and assign a probability, a percentage chance of them being a high-risk versus low-risk applicant.
So it's still about prediction, but instead of spitting out a number, it gives you a likelihood, a degree of confidence in a particular outcome.
Exactly. And that's incredibly useful in all sorts of scenarios, from spam filters figuring out which emails to flag, to medical diagnoses assessing the likelihood of a particular condition.
Okay, I'm starting to see the method behind the madness here. So we've covered predicting continuous values with regression techniques. What about those classification tasks you mentioned? How do we teach algorithms to sort things into neat little categories?
That's where classification techniques come in. Think of sorting a mountain of emails into important and spam. Classification algorithms are like those super organized assistants we all wish we had, sifting through data and putting things in their rightful place.
Sign me up to that. So what kind of algorithms are we talking about here?
One of the easiest to visualize is a decision tree. Imagine a flowchart with a series of yes/no questions, leading to different categories at the bottom.
Okay, I can picture that. So, like, is the email from someone I know? Yes. Did they use any emojis? No. Probably important.
Exactly. And then we have random forests, which is like combining the power of multiple decision trees. Think strength in numbers for more accurate predictions.
Like a whole committee of decision-making trees, each voting on the best category.
And for the truly adventurous, there are support vector machines. These are incredibly powerful at finding those optimal boundaries between categories, even in really complex data sets.
Sounds intense. But for now, I'm happy to have my committee of decision trees. Okay, so we've got algorithms that can predict continuous values and classify things into categories. What other tricks do they have up their sleeves?
Let's talk about clustering techniques. These are the detectives of the machine learning world, sifting through data and grouping similar items together without any predefined labels.
So instead of telling the algorithm, these are apples, these are oranges, we're saying, here's a basket of fruit, figure out what goes together.
Precisely. And one of the most popular clustering algorithms is k-means clustering. Imagine you're throwing a party and want to arrange snacks so everyone can easily reach their favorites. K-means would be like your strategic snack placement guide.
Ooh, strategic snack placement is crucial for a successful party. So how does it work?
You decide on a number of clusters, that's the K in k-means. The algorithm finds their centers and then assigns each snack to the nearest cluster center.
So you could have your veggie platter cluster, your cheese and crackers cluster, your dessert cluster. Everyone's happy.
Exactly. Now, if K-means is like organizing snacks, then hierarchical clustering is more like building a family tree of data.
Okay, I'm intrigued. How does building a family tree apply to, say, my music library?
Imagine tracing the lineage of your favorite band. You start with the current members, then branch out to previous members, and so on. Hierarchical clustering works similarly, but with data points instead of band members. It groups similar artists together, creating a tree-like structure that shows how musical styles have evolved and influenced each other.
So you can see the whole history of how things are connected, from the individual data points all the way up to the bigger picture.
Exactly. And then there's DBS Scan, which is great for dealing with data sets that have a lot of noise or outliers. Imagine trying to identify clusters of stars in the night sky, but there are also city lights and airplanes interfering with your view. DBS Scan excels at filtering out that noise and identifying those core clusters of stars.
That's amazing. So
Yeah.
we've got algorithms that can predict, classify, cluster. It's like having a whole team of digital data analysts at our disposal.
And we've only just scratched the surface.
Yeah.
Things get really interesting when we start talking about deep learning.
Deep learning, it's like we've reached the boss level of AI.
It definitely feels that way.
Deep learning, it's like we've been playing with the building blocks and now we're ready to construct some truly mind-blowing structures.
That's a great way to put it. Remember those neural networks we talked about earlier? The ones inspired by the human brain?
Mhm.
Deep learning takes those networks to a whole new level. We're talking about architectures with dozens, hundreds, sometimes even thousands of layers, each processing information and passing it along to the next.
So it's like those neural networks have been hitting the gym, doing their brain push-ups, becoming exponentially more powerful.
Exactly. This allows deep learning models to tackle incredibly complex tasks, things that would have seemed impossible just a few years ago. Image recognition, natural language processing, even predicting protein folding. Deep learning is revolutionizing entire fields.
It's both exhilarating and a little intimidating, wouldn't you say? Like, we're unleashing this incredible power, but are we really ready for it?
That's the million-dollar question. And it brings us to a crucial point in our deep dive.
Yeah.
It's not enough to just develop powerful AI.
Mm.
We have to use it responsibly.
Right, because with great power comes great responsibility.
Okay.
So the saying goes. So
Mhm.
where do we even begin?
Well, a good place to start is with data. Because even the most sophisticated deep learning model is only as good as the data it's trained on. It's like that old saying, garbage in, garbage out.
So data quality is paramount, but what makes for good data in the world of machine learning?
Ideally, we want lots of it. And it needs to be relevant to the problem we're trying to solve.
Mm-hmm.
But it also needs to be clean, accurate, and free from biases that could skew the model's predictions. Think of it like training a chef. If you only give them spoiled ingredients, they're not going to cook up anything edible, are they?
Not unless they're into some avant-garde experimental cuisine. So how do we ensure our algorithms aren't getting a steady diet of digital junk food?
That's where data pre-processing comes in. It's like washing, chopping, and preparing those ingredients before handing them over to the chef. We might need to clean up errors, deal with missing values, or even transform the data into a format the algorithm can understand.
Data prep, the unsung hero of the machine learning world. But even with the best data, I imagine these complex models can be a bit like black boxes, right?
Right.
We know they're making decisions, but it's hard to understand the why behind those decisions.
That's a great point. And it brings us to another crucial aspect of responsible AI, model interpretability. As these models become more sophisticated, it's not enough for them to just be accurate. We need to understand how they're arriving at their conclusions.
It's like the difference between a doctor saying, you need surgery, and explaining why surgery is necessary, what the risks and benefits are, and what the recovery process will look like. We need that level of transparency, especially when these models are being used to make decisions that impact people's lives.
Exactly. And that's why the field of explainable AI, XAI, is so important. Researchers are developing new techniques to peek inside those black boxes, to understand how the algorithms are weighing different factors and making their decisions.
So it's like giving AI a voice, a way to communicate its reasoning so we can ensure it aligns with our values and ethical principles.
Precisely.
Mm.
We want AI that is not only powerful, but also trustworthy and aligned with our goals as a society.
It's a tall order, but it sounds like we're on the right track. So, as we wrap up our deep dive into the world of machine learning, What are some key takeaways our listeners should keep in mind?
Well, first and foremost, machine learning is already here, and it's transforming the world around us in profound ways, from personalized medicine to self-driving cars to the way we consume information. AI is no longer a futuristic fantasy. It's our present and our future.
And while it's easy to get caught up in the excitement, and let's be honest, a little bit of fear
Yeah.
surrounding AI, it's important to remember that we have a say in how this technology is developed and used. We need to approach AI with a critical yet optimistic perspective, asking tough questions, demanding transparency, and ensuring it's used for the betterment of humanity. So, as we turn the page on this episode, here's a final thought-provoking question for our listeners to ponder. What role do you want to play in shaping the future of machine learning?
Because the future of AI isn't predetermined. It's a story that's still being written. And we all have the opportunity to contribute to its narrative.
Keep those brains buzzing, folks. Until next time, this has been The Deep Dive.